All right, so let's start with an example for the method so-called variation of parameters to obtain a particular solution of a non-homogeneous differential equation. So let me consider this problem. X prime equals minus 2, 1, 1, minus 2, x plus 2 times e to the power minus t and 3t. So this has the form x prime ax plus g, right? Where A is this matrix and G to be this non-homogeneous part. We will also call this external force function later. So let's apply our method. What was our method? First, we need to find the solution of the homogeneous equation, which we call a complementary solution, right? So xc is the general solution. So this is the complementary solution. In other words, it is nothing but the general solution of the homogeneous equation, of the associated homogeneous equation, okay, which is just x prime equals ax. Okay, and xp is a particular solution. We will use the method we described last time. All right, let's start with x sub c. So my complementary solution, of course, will be obtained from this as the solution of the homogeneous equation. A was minus 2, 1, 1, minus 2. From this, we write characteristic equation, which is just r squared plus 4r, right? Trace of a times r plus, no, minus trace of a times r plus determinant of a equals 0. So this is just r squared, trace is minus 4, so it is plus 4 plus determinant 4 minus 1, which is 3. And from this we get r plus 1, r plus 3 equals 0. So r1 is minus 1 and or minus 3, let me say. Well, did I make a mistake? No, okay. Yeah, correct. Yeah. Minus 3 minus 1. Okay, for minus 3, let's find an eigenvector. So A minus R1 times identity V1 equals 0. From this we get, so A plus 3 times identity V1 equals 0. So I add 3 times identity, so it becomes this. V1, let's say AB equals 0, 0. From this we get this equation A plus B equals 0. So let A equals 1, then B is minus 1. So V1 can be taken as 1 comma minus 1. And the corresponding solution actually what will be the solution? E to the power R1T times uh, V1. So it is just what? E to the power R1T. No, R1 is minus 3, and then minus e to the power minus 3t. For the eigenvalue minus 1, so we R2 times identity V2 equals 0. So this time we get this. Okay, so I add identity. So when I add identity, it was minus 2, so it became minus 1 and 1 minus 1. And let's say this is CD equals 0, 0. So from this, the only equation we get minus C plus D equals 0. The other equation is the same. So let C equals 1, then D equals 1. So V2 can be taken as 1 comma 1. And the second solution is just e to the power R2t times V2. So it is e to the power minus t times 1, 1, or just this. Okay. So these are linearly independent two solutions. What is the fundamental? Okay, so x sub c is just, we take these as columns, right? As columns. So it is just, what was the first one? Okay, e to the power. So I take the first solution and take the second solution and write as the columns. So we get e to the power minus 3t minus e to the power minus 3t, e to the power minus t, and e to the power minus t. Well, this is the fundamental matrix, a fundamental matrix. So it is not the, because when I plug 0 for t, I don't get the identity matrix, okay? If you want to get the identity, I mean the fundamental matrix, then you have to compute e to the power at, okay? But we don't need at this moment. So what is the complementary solution? It was fundamental matrix times this, so it is e to the power minus 3t minus e to the power minus 3t, e to the power minus t, e to the power minus t, and then c1, c2, where ci's are arbitrary, real, and actually complex numbers. You can take also complex numbers. Okay. What about the particular solution? XP particular solution. Okay. So we have described a method, right? What was it? It was variation of parameters, and it was as follows. So you take the fundamental matrix and multiply it with the integral of the product of the inverse of the fundamental matrix times the non-homogeneous part. Okay, so let's check whether we have copied it correctly. Yeah. Okay, so fundamental matrix times the inverse of the fundamental matrix times G integral. Okay. But for this, I need the inverse of the fundamental matrix. fundamental matrix is this: e to the power minus 3t minus e to the power minus 3t, e to the power minus t, and e to the power minus t. To compute the inverse, first I need to compute the determinant. So it is e to the power minus 2t, no, 4t, another minus 4t. So it is e to the power minus 2 times e to the power minus 4t. All right. So what is the inverse then? It is just 1 over the determinant, 1 over the determinant times, you do what? You interchange the diagonal ones and multiply the off diagonals with minus 1. Right? Interchange the diagonal ones and multiply the off diagonal ones with minus 1. So that's it. And this is just 2 times e to the power 40. 1 over that will be just 2 times 1 over 2 times e to the power 40 multiplied with this e to the power minus t minus e to the power minus t, e to the power minus 3t, and e to the power minus 3t again. Yes, so what is this then? Well, this is just 1 over 2 times. Okay, I multiply with e to the power 40, the matrix. So I get e to the power 3t minus e to the power 3t, and then e to the power t and e to the power t. All right. So this is the inverse of the fundamental matrix. So what about the solution? Xp t. Well, that was the fundamental matrix. Let me put it here. Times this gadget, but I write it with S. Okay, so with S, so I have 1 over 2 times e to the power 3s e to the power s minus e to the power 3s e to the power s times gs. G was e to the power 2 times e to the power minus t, so I write s here, and then I had 3t, so 3s, and then we have ds. Okay, so I multiply it out. Okay, let me put minus 1 over 2, no, 2. All right, let me write it this way. Integral. So this is just 2 times, all right. So 2 times e to the power 2s minus 3s e to the power 3s. And then I have 2 plus 3s e to the power s. And then we have ds. Let me check. Yeah, 2 times e to the power 2s minus s times e to the power. Yeah, this is s. And then, okay, so let me see if I have done correctly. Now we have to compute this integral. So I just take integral of each, entry. So integral of 2 times e to the power 2s is just e to the power 2s divided by 2 minus 3 times integral of s times e to the power 3s. So what is this? This is just integration by parts. So s times, let me keep this and take the integral of this e to the power 3s over, so 3s over 3 minus derivative of this times integral of this e to the power 3s over 3. Yes, right. This is, let's say, u. This is dv, u v, and then du v, and integral of this is just so this is s times e to the power 3s over 3 minus integral e to the power 3s over 9. Okay, so I have 3 times this gadget. 3 times this gadget will be just 3 times this s times e to the power 3s plus e to the power 3s over 3, right? Minus 3 times this gadget, minus 3 times this gadget, minus s times e to the power 3s, and then plus e to the power 3s over 3. All right, and then integral of 2, which is just 2s, plus the same thing, just minus sign, so it is s times e to the power 3s minus e to the power 3s over 3. Okay, I have also plus c1, c2 terms, but just take them to be 0 because all I want is just one. Evet. Okay, okay. Şurası değil mi? Tamam, özür dilerim. Orada şey olacaktı. S olacaktı. S olunca bu 3 yok. Değil mi? Şurada 3 yok. Burada 3 yok. Burada 3 yok. Burada 3 yok. Burada 3 yok. 3 yok. Ee, bu 3'ler yok. Yani S çarpı E üzeri S ama 3 ile çarpıyorum. Evet, 3 ile çarpıyorum. Burası 3S E üzeri S eksi 3 tane E üzeri S. Şimdi tamam sanırım, değil mi? Peki buradan şimdi 1 over 2 times phi neydi? Onu da yazalım. Tabi burada integrali alıyorum. S bu sıfırdan t'ye alıyoruz. Sıfırdan t'ye aldığımıza göre yani şurada 0 t koyacağım. Sıfırdan t'ye alırsam şimdi şöyle yazayım. T koyduğuma göre e üzeri 2t eksi t çarpı e üzeri 3t artı e üzeri 3t bölü 3 2t artı 3t e üzeri t eksi 3 e üzeri t eksi 0 koyuyorum. 0 koyduğumda dikkat ederseniz buradan bir constant gelecek. Buradan da bir constant geliyor. O constantları yazmak zorunda değilsiniz. Yani C1, C2 olacak. Ama onlar hani homojen kısmın içine atılabilir. Yani yazsanız da sorun değil orada. Evet. Yani normalde zaten artı C1, C2 demem lazım. O constantları bunun içine attığımızı düşünün. O yüzden böyle de bırakabilirim. Peki buradan 1 bölü 2 çarpı bu matris neydi? Bu e üzeri eksi 3t, e üzeri eksi t, eksi e üzeri eksi 3t, e üzeri eksi t idi. Bunu alıyorum. Bununla çarpıyoruz. E üzeri 2t eksi t çarpı e üzeri 3t artı e üzeri 3t bölü 3. 2t artı 3t e üzeri t eksi 3 çarpı e üzeri t. So it is this one. You have to do also this multiplication, and this is your xp. Okay, so this is my xp, particular solution, and the general solution is nothing but the complementary plus the particular. Okay, complementary solution was the fundamental matrix times this. So you see here I have already C1 C1 C2 multiplied with the complementary matrix. So that's why, you know, if you had here plus C1 C2, that would be just go into those, you know, constants. So I can just leave it like this. All right. Any questions so far? Okay. Well, so I will finish this section at this point. So you will be responsible up to here from you know, for the exam. Okay. Yok, kamera olmayacak. Yani open book olacak. Çünkü benim zaten kontrol etme şansım yok. O yüzden hani kamera olmayacak. Open book olacak. İşte 2 saat süreniz olacak vesaire. Tamam mı? Hı. Okay. Now so exam will cover up to this point. Now I will start so-called chapter 3, second order linear equations. Since we changed the order of the you know, book, I first covered systems, right? Therefore, I will use the theory built there to study, you know, second order ordinary differential equations. What we will do, we will just convert second order linear equations into systems, and then we will just apply our methods to obtain a solution for that system, and then I will again convert this solution to the solution of the ordinary differential equation. So an nth order linear differential equation has the form remember it was like this. So a1 t and minus first derivative, sorry, and goes like this, a and t, the zeroth derivative means, maybe I should write n minus first, so the first derivative, and then the zeroth derivative, which is the function itself, equals gt. Okay, where aits are and gt are some functions. of t. Okay, in this chapter, we will consider only constant coefficient equations. In this chapter, we will consider constant coefficient uh, equations, so that all these AITs are just constants. Okay. Okay. So our equation has this form then. Some constant times n minus first derivative, and then, but gt is still a function of t. Okay. So AIs are constants. They can be real or complex. Okay. We will see later that, when AIs are not constant, things get, theory is nice, but things get complicated. Okay, they are not actually easy. So we will consider them later. First, we will consider only this kind of equations. Let me write down an example. Something like this, for example. Okay, an example of this type. All right, so how to solve such equations? Well, we will consider systems. So we will convert this gadget into a system. So idea is convert this equation to a system. Okay. How? We will do as follows. So let's say nth derivative of y, a1, n minus first derivative, and goes like this: an minus 1 y prime a n y equals gt. So how do we change this to a system? System actually of first order. So we will we will convert this to a first order system, and this is how we will do it. So I will let x1 t to be just yt, x2 t to be y prime t, and so on. So x and t will be just nth derivative. Okay. No, n minus first derivative, sorry. x1 zeroth derivative, x2 first derivative, xn is the n minus first derivative. Well, and let xt, big xt, just the matrix of this functions, the column matrix of these functions. So xt, x1t, x and t. All right. Then what are the derivatives? So what is x prime? So what is x1 prime? x1 prime is just y prime t, but y prime in terms of x is just x2t. What about x2 prime? Well, that is y double prime, but y double prime is just x3t, okay, and goes like this up to x n minus 1 prime. That is just x1 minus 1 n minus second derivative. So its derivative will be n minus first derivative. Well, that is just x n t. And what about x n prime? Well, that is nth derivative of t. What about nth derivative? Well, nth derivative is not listed here, but I can just write nth derivative from this. So it is what? It is a1 times yn minus 1. So it is just n minus 1. So, or maybe I write it. Okay, let me change this ya da kalsın. Okay. It is minus an times y, which is x1. So minus an times x1, right? Minus, I take this guy to the other side. So it is minus an times y. Y is just x1. So it is minus an times x1. And then minus an minus 1 times x2 x2 will go up to where an, so a1 times the sum is n minus 1, so xn, okay, right? Yes. Ne demiştim, bir saniye. a1 times xn minus a1 times xn, evet, xn bu, evet, artı gt plus gt. So what is x prime then? X prime is just this. X prime. X1'in türevi x2 oldu. X3 böyle gidecek. Xn ve en sonuncusu minus an x1 minus an minus 1 x2 minus a1 xn and then plus gt. So it's a column matrix, n by 1 matrix, and it has this form. And I can actually write it as what? As follows. So this is nothing but, 0 times 1 times 0 times 1, 0, 0, and then 0, 0, 1, and then zeros. It will go like this up to the last row, and then the last row will be minus an minus 1 up to minus a2 minus a1, and then here I have x1 x2 xn plus 0 0 and then 0 finally I have GT. Okay, so we have this system. Okay, we have this system. All right. So our equation, hence, the equation, what was it? Nth derivative plus a1 n minus first derivative an y equals gt is equivalent to the first order system x prime equals ax plus g, where a is this matrix 0 1 0 0 0 1 0 goes like this, and here I have minus an and then up to minus a1, and then and gt is just 0 0 up to well, gt. Okay, this notation is a bit awkward, but you know. So here this g is scalar function, but here it is maybe I write it this way. Okay, let me call it g. Yeah. Okay. All right. So and of course we know what we know how to solve this. Is this system, this is a constant coefficient equation. We know how to solve it. We know what is the general solution and so on, right? So let's see what we get. First, let us consider let us consider non-homogeneous equations. So that let gt equals 0 and this big gt equals 0 matrix. So so our equation then will be just this gadget where A is this matrix. Well, how can we solve this? We solve this finding eigenvalues and eigenvectors, right? A canonical form of the equation. So the matrix. So let's find characteristic equation of A. So what is this? This is just determinant of A minus R times identity. So I have this matrix then. What was it? A, okay, so minus R and then 1 0 0 0 minus R 1 0 0. It will go like this up to 1 here minus R, and the last row will be what? Minus an minus 1, değil mi? Evet. The last entry will be minus a1 minus R, and we have determinant of this equals 0. Let me just do, two special case. So let's say, so special case. Evet. Minus a an olacak. Tamam. Tamam. Okay. Special case, let's say degree 2. Okay, a1 y prime plus a2 y equals 0. Okay, so in this case we have 2 by 2 system. 2 by 2 system. So what will be the matrix? So x1 is just y, x2 equals y prime, right? And my equation will be this. Okay, so x is just x1, x2. So x prime is just x1 prime, x2 prime, and it will be 0, 1, and then minus a1 minus neydi? A1 yok. A2 neyse şöyle yazayım daha iyi olacak. Şimdi x1'in türevi nedir? Y'nin türevi yani x2. x2'nin türevi nedir? Y double prime. Y double prime da nedir? Eksi a2 çarpı y eksi a1 çarpı y prime yani eksi a2 çarpı x1 eksi a2 çarpı x2. Dolayısıyla da bu şuna eşit. Şurası da x2 idi. Yani bu 0, 1. Burası da eksi a1 eksi a2 x1 x2. So my matrix A is just 0, 1 minus a1 minus a2. What is the characteristic equation? It is just a determinant of a minus r times identity. So it is just minus r 1 minus a1 minus a2 minus r. Bu da nedir? R kare eksi r kare artı r çarpı a2 artı a1. Evet. Hı. Yani onu nasıl yazdığına göre böyle yazarsam o zaman bu şekilde olacak. Öyle değil mi? Yanlış mı yaptım? X2 prime y'nin ikinci türevi. Y'nin ikinci türevi de eksi a1 çarpı y prime. Eksi a1 çarpı pardon yanlış mı yaptım? Eksi a1 çarpı şu a1 y prime x2 burada da evet haklısın şurası 2'ye 1. Tamam. Özür dilerim. Tamam. 2'ye 1. Yani burası 1, burası 2 oldu. Tamam. Tamam. Well, note that uh, the characteristic equation uh, which is just 0 or r squared plus a1 times r plus a2 equals 0 is nothing but the differential equation which is y double prime plus a1 y prime plus a2 y equals 0, right? This was my equation, right? a1 a2 where derivatives of y, where kth derivative of y is replaced by r to the power k, right? So second derivative of y is replaced with r squared. First derivative of y is replaced by first power of r. Zeroth derivative of y is replaced by r to the power 0. So the characteristic equation of the system is just the polynomial obtained by replacing derivatives of y with powers of r. Okay, kth derivative is replaced by kth power, and we will see that actually this is not something special to second order equations, but this is true in general. Okay, and then we will just write down the roots and so on and continue. And let me stop here. In the second hour, I'll do this in more generality and then write down the solutions. Okay, so let me give a break.